So, you want to get a large 3D printer, right? Who doesn't want a large 3D printer, right? They're awesome. Look how big this thing is. I can print full chest pieces for a T-45 power armor. I can print this 600 millimeter tall Dark Fortress Abattoir in one print in like under a day. And I get why people want a large 3D printer. I was in that boat at one point too. My very first 3D printer was a Monoprice Select Mini. And the second printer I got after that was a self-built Voron V1.5, 300 by 300 by 400 millimeters. In 2018, that was a pretty large 3D printer. And now I have this, the Fysetc Venture XL. It's 600 millimeters cubed. It's a flying gantry Core XY, and it is amazing and awesome and great until it's not. So it's been a little bit since we've done a video on this channel. However, if you've been watching the live stream, you know this bad boy can fit so much content in it because I've been tweaking and fixing and just working on this thing for the last couple months. So I'm going to do a video today going over everything I've had to fix, upgrade, tweak, adjust, tune, and the ongoing issues I'm still having with the Fysetc Venture XL, and we're going to touch on large format 3D printing in general as well. So let's get started. I guess we'll start with what has happened majorly since the last video. And the first thing is, this whole printer has been pretty much rebuilt. After the last video, things were going pretty good with this printer. I had a list of things I had planned on upgrading on the printer, and some of them I've done, like enclosing it. But then one day, it just stopped working. CAN bus issues, unfortunately. So what do I mean by that? Well, this printer was a Fysetc kit. All the electronics are from Fysetc, and it ran CAN bus. So we had a cartographer probe that was attached to a Toolhead board, that was attached to a MCU-powered controller board, and then that was attached to the front screen, and the front screen ran the Linux SoC. And with CAN bus, it's all daisy-chained, right? One connects to the other, connects to the other, connects to the other. And we lost the cartographer probe one day. It just stopped communicating. Now we tried a separate cartographer probe. We tried switching it from CAN bus mode to USB mode. There's streams where I went through all of it. Believe me, it was all done live. It was a lot of troubleshooting. And eventually we got to the point where I just said, you know what? Something's wrong with the electronics in this printer. I have an early version of the Fysetc Venture XL. Fysetc has actually redone the printer with a new main controller board. I had the original one. Apparently it had issues with static electricity or something. I don't know. So at that point, instead of hunting gremlins continuously, because we couldn't figure out what was wrong, it would not work, and I didn't trust the electronics that came with the printer at this point anymore, I gutted it all. So I reached out to our friends over at BigTreeTech, and they sent me a box with some electronical goodies that we crammed into this printer. So this printer has all new brains and smarts. We now have a EBB36 Gen 2 Toolhead board. I've paired that actually with a beacon probe. This kit did come with a cartographer probe. I have used cartographer probes in the past. They have worked well until they just didn't. I had an extra beacon laying around. I trust the beacon probes a little bit more. I have slightly better results. I can never get cartographer tap to work, but beacon, it just works. So this now has a beacon probe in it. The EBB36 Gen 2 is on USB as well. So now we are USB to the main controller board, which is a Kraken. And because we kept the original power supplies, we are running 48 volts for our motors with the Kraken as well. And also the Linux SoC on this printer now is a, what is it? The BigTreeTech Pi 2. So it's their version of the Raspberry Pi, their Linux SoC. And then of course we do have a little 5-inch touchscreen here, and it's differently mounted. I kind of like the position and the size of this screen more. I usually use my printers, I control them with the computer that I have in the garage here. So the screen on these printers is usually secondary for me, and it being small and out of the way, I'm less likely to bump it instead of the stock screen that was just sticking out the front. So as you can see here on the Toolhead board, we have our new Toolhead board itself, the EBB36 Gen 2. It's been working pretty good so far. I've really had no issues with that. We have the cartographer here, and as you can notice, this isn't the stock Toolhead as well. The stock Toolhead with this printer was a stealth burner. I have swapped this over to the A4T Toolhead. Shout out to LDOmotors. I totally did not steal one of the Toolheads out of your stealth burner kit that you sent me so that I can use the extruder and fans and whatnot to build this A4T, but I did it, so here it is. Also, under here, we've upgraded our hot end. This is a LukesLab Chibi Tube, the Tube Compact. I'm having really good results with this hot end right now. I have it paired up with a 0.6 Fysetc silicon carbide nozzle right now, and it's working pretty good. It's a nice little package. I originally wanted to go with a 0.8 nozzle because, you know, it's a large printer, but the 0.6, I find it's a good mix between the detail quality of a 0.4 and the speed of the 0.8. So I've been printing with a 0.6 nozzle, 0.3 layer height for pretty much all the profiles on this printer, and it's been going pretty good. As you can see, we also have an umbilical now. I got rid of the drag chains as well, so we have an umbilical. I'm trying out like a hybrid style here where it comes vertically up and then we have a swing arm back here. I have a couple hundred hours of it printing like this. It doesn't droop down, it doesn't get in the way. It's actually working pretty good. We have a little thermistor I kind of jury-rigged here to get a chamber temperature. And in the back, this is where our filament comes in. It's a Bowden tube, comes in here and meets up with the rest of our umbilical. And it's working pretty good. The stock motors are still in, so these are NEMA 17s, the tall boys. But guess what? The stock fans, they died. Both of them did. They died pretty quickly. So I just grabbed some spare fans that I had lying around and just screwed them to the heat sinks. And good enough, it's working. Also, I swapped out these pulleys. There was some weird issues with VFAs in this printer and print quality that I spent way too long diagnosing. So basically everything that was that could affect how the printer prints, I rebuilt, and including swapping out parts that I kind of had a little sus about. So those have been swapped out. I did try using tooth idlers here to see if that would affect print quality. It didn't. So I went back to the smooth idlers. And also another small thing that caused a bit of a problem. The A4T toolhead, it's actually shorter than the Stealth Burner toolhead, and it actually sits up higher on the mount. So on the 3D printed normal Voron mount, that's not a big issue. But on the CNC mount that came with the kit, I actually had to trim off about like 5-6 millimeters off the bottom of it. I don't know the exact number off the top of my head, but I had to trim the mount down so that the A4T toolhead would fit properly and the nozzle would be the lowest point on the toolhead, which caused a bit of a problem. And that problem is these carriages for the Z rails were now hitting before the nozzle reached the bed. Now luckily there was enough adjustment in the springs in the bed to raise the bed up enough that I could get it working again. But that was something that I had to sort out, and I didn't know that was going to be a problem, and it became a problem, and then I had to resolve that problem. Also, while I got the bed here, one thing that a lot of people don't realize about big printers, they have a big bed, and this is one singular flex plate. So 600 millimeter flex plates, they're not the most common online, they're not the cheapest online, and this kit came with one. So it really sucked when I did a Z-negative China and gouged the heck out of one side of it. Now, luckily, it's just cosmetic. It does still work. It's just, you know, if I print on that side now, I have a random line across the bottom of the print. Getting some components for large printers like this, it's going to cost a little bit more. It's going to be a little bit more trouble. So that's something to keep in mind if you are looking into getting a big printer. And while we're in here, the camera itself is the included camera that came with the kit. It is a Logitech C270. I moved it to the back of the printer instead of the front. Still the stock Z motors, and we've added some lights as well. These are just daylight on a stick that I had lying around that I installed there. So that's about all I've done on the inside here. So let's go look at the electronics box. So back here, first thing you'll probably notice, it's a filament runout sensor. This is a Triangle Lab filament runout sensor I've had for years. I just put it on a mount, stuck it on the side of the printer in line with the filament feed path that I have rigged up for now. And it's good enough. It lets me know when it runs out of filament. We now have a BigTreeTech crack in here. Still the stock fan, still the stock power supply, solid state relays and everything. But I did put a Kraken in. There is a mount that you can print that basically allows you to swap it directly in without having to drill and mount new holes. This is really nice because with the Kraken, I'm actually running a stock version of Clipper. I'm not running whatever version of Clipper with their config that Fysetc sent with the printer itself. I'm just running literally a stock V2 profile with stuff adjusted to fit the larger size of the printer, the add-ons I have, and obviously the 4 independent beds. Now you might be wondering, in that electronics box, there's no controller board. Where did I put the controller board? For that, we have to dig. And by dig, I mean we have to go under the printer. And welcome to underneath the printer. One thing I do want to say that's been great so far is the actual stand that I built for the printer itself out of 2x4s here. We have the casters mounted underneath. So the casters that came for the kit, because the kit is, I guess, supposed to sit on the ground directly. I didn't want to be leaning over to work on a printer. So I built this 2x4 stand for it to sit on, and it's been working great so far. And it's great because I can get under the printer to work on stuff without having to flip the printer over, which is really nice with a big printer. But under here, you can see where I mounted all the new brains of the printer. So we have the BigTreeTech Pi 2 right here. We have a breakout board right there. We have some Wagos. We have all the wiring there just kind of tucked up underneath. And I just have some easily removable insulation panels here just to keep extra heat in because, you know, these panels that come with the kit are pretty thin and I don't want to be losing heat because my garage gets cold in the winter. So we have all this under here and that's where that stuff is. We have the little Wi-Fi antenna sticking out the side. With the BigTreeTech Pi 2, I've had no issues with it functionally, except for the fact that if the printer's been on for a while, the Wi-Fi kind of just dies. It still works, it just gets really slow, like it buffer overflow or something. At some point, I will hook up an Ethernet cable so I don't have to deal with Wi-Fi anymore, and hopefully that fixes that issue. Now, a big printer in a cold garage is not a good thing, especially when you're only relying on the bed itself to heat the chamber. So you want to trap as much heat as possible. And for that, instead of using the panels that came with this kit to insulate it, I went out and got these panels. Now, these are 1/2-inch thick insulation panels. They are, how do you pronounce this? Polyisocyanurate boards. These were recommended to me by Luke from LukesLab. I guess this is what he uses to enclose his printers, the StableBots. And I'll say it's been working pretty good with just those panels on the 2 sides and the top. The back, I did reuse some of the, I think those black panels back there are actually from the top of the printer. And then I have some Reflectex here with a little slot in the middle for the Bowden tube to come in and out. With the 3 sides and the top being insulated and with just the stock front doors on, when I'm printing ABS in here with the bed at 100 degrees Celsius, I am getting a chamber temperature, surprisingly, in the 50s. I do need to add some fans in here to get the air circulating still, but it is hot enough to print ABS, and I can prove that because this giant Judge Dredd print here, this was printed in ABS. This is Polylite ABS, and it printed fine in here. No layer issues, no cracking. It printed fine in here, and it was pretty chilly in the garage when it did that. So the insulation panels are working pretty good, and that is great, except for the fact, ever since I enclosed this printer, I can only print when the printer is hot because the printer expands now. I didn't have this issue when the panels weren't on and it was still not too cold out here, but ever since I enclosed this printer, I have been having issues with print quality, and the reason is this gantry is expanding. So if you've been following Voron development for a bit, you probably know the Phoenix has been in development for a while, and one of the things we've realized is that this X gantry here, when you have it in an enclosed chamber and it gets warm, it expands more than the frame itself. The frame, you know, while I have insulation on it, the frame is exposed to outside. So this frame doesn't get as hot as this part of the frame. So this expands, it pushes on the Y rails, and it actually causes the carriages to start grinding and binding. So what I've done for now is essentially I've heat soaked the printer. I cracked my XY joints and my rear extrusion there. And basically this printer is set up now so that it can really only print when the chamber is warm. So I basically tuned it for printing hot, and that's what I've had to do. Now, I probably at some point will sort out some sort of expansion joint somewhere in here to make it, you know, work so I can print, you know, open door with PLA and then close the doors and print ABS. But as it is right now, if I wanted to print PLA in this machine, I would have to retune my gantry and adjust things so that I don't have grinding issues, because it causes print defects, which is not good. Yeah. But I will say, after swapping out all the electronics on the printer, reinstalling Clipper, rebuilding the tool head, redoing the umbilical to go away from drag change, swapping out some bearings, swapping out some pulleys and whatnot, and insulating the thing and doing all the other stuff I've done, there's a whole list of streams that if you want to see everything I've been doing to this printer, because everything I've done to this printer has been on streams. It is actually printing pretty good now. I have been using it to print the final parts for the T45 power armor that I'm building. I have used it to print a bunch of CF PETG for an astromech droid I want to build. Is it the most stable printer in the world? Probably not. One big issue I'm running into is power. Power has been a problem with this printer. One, it uses 4 beds. I have 2 20-amp circuits in my garage. I accidentally ran this printer while also running another heater in the garage, and it blew my breaker. Now, luckily, it's, you know, a modern breaker. I just flip the switch and everything comes back on. But this draws a lot of power. And 2, I can't really put it on a UPS. And the reason for that is the plug. Where's the switch? There it is. Turn the printer off. This plug that this printer uses is a 20-amp plug. All the UPSs I have are 15-amp UPSs. I can only plug it in with, you know, a normal, what is it, C14, C13 plug, not the 20-amp plug. So what I actually plan on doing, because I still have things I need to do to this printer, is I'm going to split the power delivery of this printer. What does that mean? Well, the 4 beds will draw their power from the 20-amp plug, but the electronics and the brains of the printer, so the motors, the Raspberry Pi, the MCU, the hot end, all that stuff, that will draw from a separate plug running at 15 amps, so that way I can at least run this printer on a UPS. So what does that mean? If my power flickers, which is like the worst kind of power outage I have here, where the power just goes off for a second, and that happens once a month or every 2 months, but when you're doing 36, 48-hour prints, that's a risk. So at least that way, if the power does flicker and the printer does lose power for a couple seconds, yes, the beds will turn off, but there should be enough ambient heat in there that thermal runaway won't kick in, and it'll still be able to keep going, and then when the power resumes, the beds will just resume, hopefully. So that's the thinking. That's still on the list of things I got to do. But yeah, that's where the printer's at right now. So if you have any questions about the Venture XL, or you want to see me go into something a little bit more in-depth about what I've done with it, let me know in the comments below. As I said earlier in the video, I'm still working on that power armor. In fact, as of right now, the lower half of it is just about done, and I've got all the main upper body parts printed, and I'm on the post-processing part of that. So if you want an update on the power armor build, I know it's been a while, let me know about that in the comments below. So I hope you enjoyed this video. I had some people on stream asking about the printer and everything I've done with it since I got the build finished. Excuse the mess, my garage is a mess. It's winter, it's a garage, it is what it is. So yeah, so I hope you enjoyed this video. Like the smash button, ring the bell, subscribe if you're not subscribed. I'm Taylor the Canuck creator. This is the Fysetc Venture XL, and big printers, they're always kind of a work in progress. Cheers.